Example 4, it says, find y prime 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 of 3, third derivative, if y equals the square root of 5x minus 4. And as always, as I've been harping on since section 3.3, structure is the key to establish how you're going to differentiate. We don't want to differentiate radicals, we'd rather differentiate powers. So 5x minus 4 is the radicand, is raised to the first power. This is the square root, so officially this is y equals quantity 5x minus 4. Oops. My minus too quickly. 5x minus 4 to the 1/2 power. Changing from a radical to a fractional power is algebra. We don't change the y doing algebra, so it's still y equals, using a notation in our work. Now, looking at the structure of this, I have a power structure, and I've got a function raised to a power, not x raised to a power. That tells me the chain rule is necessary to differentiate. So, if I differentiate this, I'm going to get y prime is going to equal 1/2 times 5x minus 4 to the negative 1/2. That's just the power rule happening there. Power rule is a calculus step, so notice y changed to y prime. I took a derivative. Since 5x minus 4, the base has a derivative of 5, I'm going to multiply that times 5. And if I simplify that out, y prime equals, I end up with 5/2 times 5x minus 4 to the negative 1/2 power. Okay. I'm going to continue differentiating. I'm trying to find the third derivative, so I'm going to keep it in a good structure for differentiation rather than make it pretty. So if they'd said, hey, find the first derivative, find y prime, I probably would have ended up with 5 over 2 times the square root of 5x minus 4. Okay, that's a good finishing answer for a derivative, but I'm still differentiating, so I want to keep it in this power structure in order to differentiate. I don't even want to move the 1/2 power to the bottom. I want to keep it out there, because now look at what's happening here. We have a number times an object raised to a power. So again, it's a power structure, so the power rule for differentiation works again to do a derivative. So y double prime, I take negative 1/2 times 5/2, that makes negative 5/4. I'm going to do 5x minus 4, I reduce the power by 1, negative 1/2 minus 1 is negative 3/2. Then I got to multiply by the derivative of 5x minus 4, which is 5. Again, that is the second derivative, that's the correct answer for it. It's not as simplified as it could be, but it's pretty good. Shrink this down a little bit so I can fit this whole thing on the page. Alright, so if I make this a little bit prettier for the sake of differentiation, negative 5/4 times 5 makes negative 25/4. And then 5x minus 4 stays to the negative 3/2 power. Again, leaving it like that so it's still in the numerator, so it's still a power structure, rather than putting it in the denominator, making a quotient structure. Again, if my directions were, hey, find the second derivative, I could have taken this guy here and made it simpler, y double prime equals, and then this would be negative 25 on top, and 4 times 5x minus 4 to the 3/2 on the bottom. Pretend that's a 3. It's hard to write a 3 on this board for some reason. Alright, so, and if it's 3/2, I'd leave it like that. You could also go the square root of 5x minus 4 to the third power. That's also the same thing, but if it's like a 1/2 power, just a radical, it's simple. If I start putting powers in, I usually just leave it as a fractional power myself. Alright, so again, if I'm finishing, if I'm done, I would probably go here. The fact that I'm continuing to differentiate, I want to keep it in this nice power structures because derivatives are easy in power structure. Number times something to a power, simply have to do the power rule, triple prime. Negative 3/2 times negative 25/4 makes 75/8. And we multiply that times 5x minus 4 to the negative 5/2 power. And then again, the derivative of 5x minus 4 is 5. Alright, now at this point I'm where I wanted to be, right? Third derivative, so now I want to make one of these pretty answers here, right? So I'm going to go y triple prime equals, and we end up with 75 times 5 on top, which is 375. And we got an 8 on the bottom, and the 5x minus 4, sorry, 5x minus 4 to the 5/2 belongs on the bottom. That would be my third derivative for that one. Now, something I've been noticing a few people trying to do here is use the product rule when it's not necessary. Let me just highlight what I'm talking about. Like right here where y prime is 5/2 being multiplied by 5x minus 4 to the negative 1/2, we see a product happening there, right? So we're thinking, well, it's a product, so we've got to use the product rule. The product rule is necessary when you have a function of x being multiplied by a function of x. 5/2 isn't a function of x, it's just a number. So if you have just a number, it's not going to affect what rule you use. The structure that matters is what has x in it. So x here is being raised to a power. That's a power structure. This constant has no bearing on your choice of differentiation technique. So if you see a power structure, use the power rule. The constant just gets multiplied by the coefficient, by the power there. If this said x, like if this was x times the square root of 5x minus 4, you have to do the third derivative. Now you got a much more difficult problem because the product rule is necessary. You're going to get more terms, and as you keep on doing it, you're going to get these bigger and bigger expressions. So, power rule is your friend. Try and use it whenever possible, but only use it when you can legally use it.